Hello everyone, my name is Jiajing Chen, a PhD student from Syracuse University, advised by Professor Sana Vilipaswa. Today, I'm going to bring the topic ViewNet, a novel projection-based backbone with view polling for future point cloud classification. Here, we show our contribution list. We first provide analysis of commonly used 3D point-based backbones in terms of the point utilization and argue that they may not well suited for future learning tasks. And we also visualize the projected depth image of point clouds, and we observe that some projections are robust to the missing points and deformations. Inspired by this, we propose our 2D projection-based backbone, referred to as ViewNet, and it outperforms the state and it achieves the state-of-the-art performance on 3 datasets. This picture shows the pipeline of the state-of-the-art work CIA for the future point cloud classification. It adopts the DGCNN, a well-known point-based backbone for this task. However, we argue that this backbone, the point-based backbone, may not be suitable for this task. The reason is that in our previous work, we had shown that a large number of points are discarded during max polling. In this study, we analyzed the number of points utilized by DGCNN for both traditional supervised classification, here we refer to it as the TSC, and the future classification on 2 datasets, ModNet 40 and scan object NN. And this is the experiment result. This column shows how many points are utilized by the max polling before and after training. And we perform the experiment on the TSC, the traditional supervised classification, and the future learning with k-fold cross-validation. We observe that with the number of points utilized for future classification being less than that for the TSC, it is hard to expect the DGCNN to extract the best set of features to describe 3D objects. Compared to the ModNet 40 dataset, DGCNN uses less points on scan object NN and provides lower accuracy. Thus, it can be inferred that missing points and deformed shapes can negatively affect max polling, causing to pick up inadequate points to represent 3D shape. And here is our another observation. You will see here we have the original point cloud without any point missing and deformation. And we also have the point cloud scanned by the LiDAR from 5 different angles. You could see in this case, the point cloud suffered the point missing. You could see here for some projections, like the back view, as the view angle change, the projection image changes a lot. However, for some projections, such as the projections in this red circle, they are very robust to the view angle changing. So inspired by this, we think if we would propose a backbone which could extract the most distinguished features among all the projections, it may be very suitable for the future learning point cloud classification task. When it comes to the image processing, the ResNet is a very widely used model. Here, we compare the ResNet with the DGCNN in the future point cloud classification task, and we found out that the ResNet is worse than the DGCNN. The reason is that the ResNet processes each depth image independently without extracting the distinguished feature among all the depth projections. So to solve this problem, we propose the ViewNet, which composed of 2 branches, point feature learning branch and projection feature learning branch. In projection feature learning branch, convolution and max polling are used to process each depth image independently and obtain intermediate efficient maps, D1 to D3, for our proposed view polling. View polling extracts the more descriptive and the distinguished features from different combinations of views, which are then fed into the point feature learning branch for further processing. The point feature learning branch learns the features describing the point cloud shape from feature maps of all 6 projections. To learn discriminative features in different receptive fields, the pixels in feature map F4 and F5 are divided onto n many bins. Each bin's feature is fed into feature head, and the bin's loss is obtained. Final loss is computed by summing up n losses. This picture shows the pipeline of the view polling. You can see here we have 5 new features map, C1, C to the C5, are obtained from 6 view features in D by using them in different combinations. 3 of the 5 feature maps are obtained by taking all pairs of opposite projection feature maps into account, that is the C1 to C3, If a small part of the points is missing, it's likely that at least one projection image in this combination of opposite projections is not affected greatly. Remaining 2 of the 5 feature maps come from triplet combination, since these 3 view drawings are able to depict an object's 3D shape. And we perform experiment firstly on the ModeNet 40 with 4-fold cross-validation on both 1-shot and 5-shot learning. You will see in most of those experiments, our method outperforms all other benchmarks. And we also performed experiment on the ModeNet 40C and scan object N. Different ModeNet 40, the point cloud in these 2 datasets suffers more severe point missing and deformation. And in this case, our method outperforms all other benchmarks greatly, much more. You will see our method outperforms all other benchmarks in all 4 experiments. And just to take this as example, you will see in the 1-shot learning, our method outperforms the CIA, the state-of-the-art network, for about 5%. And we also performed ablation study to analyze the effectiveness of beamwise loss. In this table, you could see if we use the beamwise loss, the accuracy is much better. And we also analyze the ViewNet's generalizability as the backbone. In this table, you could see we compare the ViewNet and DDCN when they serve as the backbone for different feature head. And in most cases, our network outperforms the DDCN greatly. And we also study the effectiveness of the view polling in this table. If without the CI, that means in this table, in this picture, we only applied max polling in the feature B without this feature C1 to C5. If it's in this case, without a CI, in most of the case, the accuracy drops a lot. That means our view polling should help network get a better performance. Thanks for watching.